group number 10, and the group members are Marcus, Midor, Philip, Stefan, and William. Okay, the project, the whole project is the API that we are going to use, and extreme programming, of course, where we have test-driven development, refactoring, and configuration management, and design patterns. And now our project is about iBody in an extreme fusion with Winamp through the webcam and a ping pong balls.
So this is the 6th stage that's controlling Winamp and the iBody, and the camera application has to find the location of the balls, and then it sends the coordinates to another application that's add the coordinates to point objects, and then it compares the old point objects with the new one.
Yeah.
So if the application found one of these patterns, then the applications have a state to work with.
Do you understand the whole point of the project? It's like webcam that finding these points, and then when it finds the right state, it goes to the Winamp and turn the maybe music on or something, and then the iBody will dance.
So this is the 3 OPA we're working with, and the first one for the camera is a C#.NET framework, and the second one is Winamp application, controlling play and pause and extracts and so on. And the third is the iBody, who controls the movements and sends head colors and so on.
Okay, extreme program. Yeah, we all know about this agile way of working about extreme programming. We tried to work with it as much as we could, and it was kind of hard in the beginning because it's a different way of working as we're used to, but we managed pretty well in the end. First of all, it's like the coding in pairs. From start, it's pretty difficult since we're used to sitting one by one programming. Even though we have the discussion before, it's different to just sit and watch and while the others do the work. But in the end, we went on pretty well, and we had very good discussions on how to solve the problems and so on. And it benefits us, like we could solve problems in the group. Like if we had a big problem, we could talk about it in the group, since everybody had tried and had a little bit part in the project. Everybody could discuss the solution to the problem. Another example is the refactoring we used. We had this method that worked with the point coordinates that came from the C# application. First of all, we just did a very basic program that calculated with the points object, and we made all this testing, and while we got the green lights from the tests, we could develop it further, and we could delete some code we didn't use and rename the variables and stuff like that. Yeah, we also used the SVN and the Google Code, or Code Google, or whatever. We were amazed how good this actually worked. It was really easy to work with. We used it a lot. We didn't have to use the USB stick and MSN and stuff like that to transfer code and documents. Just upload. That was really easy and fun to work with. It made it much easier because everybody could be up to date anytime. So yeah, that was good. Yeah, planning and implementation. This is what the code would look like in our in the early state of the process. This is not the real code. This is just a funny way of showing it. It's while the project is not working, we are planning the project and testing the IDs, and eventually, and luckily, we got a case where it was working. Otherwise, we would be running in this infinite loop forever. But we got a working ID, so yeah, that's good. We ended the loop finally.
How do you set to working to
It happens inside one of those methods.
Yeah, exactly. I can show you later.
Yeah, and here we have the, well, one of the ideas. The original idea was to use the Java media framework to connect the webcam to directly to the Java application. That didn't work out because, well, the framework doesn't like my webcam at all. So what we did was that we just started testing it, and then we found a very smooth way of doing it in C#. But we already had a lot of other examples for the iBody and the Winamp and a lot of structure in a semi-developed Java program. So what we did was that we connected these two programs with the TCP/IP locally on the same computer. So what happens is, if you take the next slide, that
This is good.
no. Well, what we did was that we made the C# program, and then it sends the information to the Java program, and then it processes it. So, next slide. So what the capture program does, it captures the image, and then it finds where these points are, these ping pong balls in this case, and it just sends the information about where these points are, and then the Java application does all the rest. Yeah, that's basically.
So now it's my turn. This is when we capture a picture, we run this to detect bright spots in the picture. It's pretty low res picture, just we didn't need a high res picture. So if we find a value that is light, it calls a recursive method called scan area. And the scan area, Milena, can you press the button and give me a pen? Yes. So let's say we have our picture here. Can everyone see? Anyways, so let's say we have our ping pong ball here. So we just and then we found a pixel here that is bright. So then it jumps into a recursive function, a long method, and then it will automatically check this pixel, this pixel, this pixel, and this pixel. If this isn't bright, then it doesn't care about that direction no more. Also, if this isn't bright, it doesn't care. But if this is bright, it will do like this. And then it will do and it will on all directions. And when this here comes, well, not bright, not bright. And when we have found all the white points here, that we store them in just an integer. And there is a threshold value for the integer to be big enough, so it's actually a ball. So we don't find like something like some noise in the camera or something. And that's basically nothing more.
This instance. We use that both in the Winamp classes and the iBody classes. It was very useful. Okay, test-driven development. We use this inbuilt function in NetBeans for creating tests. You know, the one we made in the lab. First, we just created those red light tests, and we run them. And after a while, we've got all green, and that made us sure of that we had a working code. So that was very good. We also did this mock object. We created a mock object connection to the C# application, and Marcus is going to talk a little bit more about these mock objects. Yes.
Okay, we have. It looks. It's actually a workaround to get the mock object to work, because what we wanted to do with it was that you could use the mouse to change these two well, points. So you just click on click on it, and then you move it to where you want it to be. But the connection does not have these functionalities, and it doesn't need them. So what do? Do you change the structure of the connection or the main program just to make this work, and then remove the code? Well, this is a workaround. This isn't well, it isn't very good actually. If the connection would need this is a rather this is a rather impractical way of doing it. But if by doing it like this, we didn't need to change basically any code in the main program or the connection. What we did was the mock connection. It needs mouse input, and it needs to be able to well, draw two squares that represents the 2 points. So what we did was we created a draw utility function that basically stores the information and draws it later, but that's not really part of it. It's just the way we programmed it. And the draw utility is created in the main program. And the mock connection is a subclass of the real connection that overrides all the functions that really do something, so it doesn't connect. And when we create this, we send the draw utility creating the main program along with it. So it has access to it, and the game panel has it. Oh, well, it's called game panel because we didn't rename it. I don't know why. And this means that this one can fill this draw utility with data, and then in the main loop, when we draw things, it just calls the draw utility if we have the simulate connection set to true. So it's a workaround, so you didn't have to change the structure just to get a mock object.
This mock object really improved our project. It was very valuable part of the project, because without the mock object, we would have to be connected to the webcam at all time, and we only had one webcam, and we were working in pairs. So this mock object was a very good way of us to still be working without the webcam connected all the time.
And the interface to the mock object is a graphical user interface for us to work with.
Yeah.
So we can see where the ball was, and if it's found, the states.
So we will have a show later.
Yeah.
First questions and then.
Yeah, and then
We have two question parts.
you can ask questions now, or when we show it, or after. Yeah. Just say.
Do you have some question on this that we present right now? Do you understand
Just
how it
scream and
works
we will
and
ask.
stuff like that?
I have a question
Okay.
about the part that you talked about, William,
Yes.
where it finds the balls.
Where it finds the balls. Yes.
When it has found one ball, or one
Yes.
tennis ball, does it continue and look for more?
Of course.
So
We use 2 balls.
Yeah.
So it will continue, and we can find how many balls we want.
It saves the pixels that it has already scanned. So if it finds this here, then when it goes back to when it's found the ball, or it didn't find it,
Then it continues
check
working the whole picture,
So you don't
the whole
check
capture.
the ones that has already been checked. That was my follow-up question.
we didn't mention it,
No.
but it's in the code.
But you're going to see, it's like finding you can have 4 or 5 balls.
This
Every
is-
time it finds a new ball.
Yeah, and this is used in this as well, because else the different recursions would check the same pixel twice, because they didn't know if it was already scanned. So that's the basic principle.
Yeah, because the next step, if we found one pixel there, you don't go back and check where it came from. You just check the other 3 parts.
Exactly. So we check left, right, up, down. And if left is not bright,
Or already checked.
exactly, then it won't check that, and it won't continue in that direction either. So it will check recursively all white pixels or bright pixels in the frame.
Yeah,
In that shape.
that's directly connected to each other.
And also that's why we have a threshold for how many pixels it must contain.
We also have it can't be too many pixels as well, because then there might be some kind of white background, or your face might show up, because it's a lot had to do with the lighting conditions and things like that.
We're not really sure exactly how much you want to know or really necessary to discuss in the presentation. You will see in the code anyway how we used it.
It's more the principles. I was.
Also, one thing we might have mentioned, I don't know. First, we had shape recognition. We calculated shapes from 4 balls. But then we thought we can have 6 cases, and it will be much easier, and it was a short project. So we made this into a full
But
split
it is
screen.
able to recognize, like, I only have 5.
But it's able to recognize more balls than 2 balls. It's
Yes.
like checking.
And then we made those cases depending on 4 quadrants in the frame we capture.
Yes.
Okay.
So we're gonna show it.
I like your idea with what was it? The mock connection. And I like your arguments to do it. But can you identify a design pattern that represents the same idea?
Yes, we could.
Yeah, I don't really know the answer for myself, but I just think that you could. Yeah, but you don't
We
know
haven't
enough.
done it.
Yeah.
Anyways. So we're gonna show you now then.
I was wondering about that also, so I wanted to know if you have it, because that is a design solution, of course. So, and it is a good design solution also, as Sandra said. So there should be, it should be included in the set of design patterns. So if it is not, then there should be a design pattern that corresponds to that, I think.
Yeah. But it's difficult, because you do something, and then you have to try and find out what it will, if there is any design pattern, and then it's not sure that you find one anyway. There might be one, but you might not always find what it's called.
We didn't go out from any specific design pattern. It's like, we just wrote the mock object, not according to any pattern. So now we have to find like a reconstruction and say we use this one.
But it's not a reconstruction, because you
No,
choose,
not reconstruction,
you choose
but
a common way of designing, and when you choose a common way of designing, there is also probably a design.
But we
pattern.
didn't do that. We just
but
wrote
that's
it.
okay. I was just wondering, but it's not reconstructing, because it's just there, and that's the great thing with it.
Okay.
Other things here with extreme programming, how what are your expectations? Any other comments or questions so far before the show?
And while we show it, you can ask, just raise your voice and ask something, and someone will answer you, hopefully.
Then we will have a release button.
So now I'm dressed in black, and I have my ping pong ball.
You look thick.
Yes, okay. I cannot use a touchpad with this glove.
You get the Halloween bike.
I kill you. Yes, no, we will adjust the camera. Sorry. Start. And also start, you know, yeah. Wait.
That's outside the studio.
Yes.
Okay.
It's bright. Can you? Okay.
It's like a
No.
This is a good way of showing why it's so hard to debug, because the lighting conditions change. Somebody moves a bit, like blocking the light from a certain direction, and we get
Kan du
different
starta
values.
med kvadranterna också?
Okay, try it.
No, vi ska ha den med kvadranterna.
Ja, men vi ser först.
Okay, first the recognition of the balls.
Yeah.
You can see the number of shapes are 2. It finds 2 balls.
Move one of the balls up, William, so you can see that that's some of the markers fall. It's a bug. It's the bug basically because the old, even if it doesn't update and move those markers away.
Yeah.
It's a very temporary solution. But you can see that it's able to pinpoint where these are roughly. It's not exact because yeah, we didn't
Så
program.
nu, vilken knapp behöver sätta på det röda?
Enable.
Enable.
And now you can see.
No, there's a size of them. So
And here you can see that it finds small pixels, but it doesn't, like, you see noises and stuff here, but it doesn't count them because they're too small. And we also have, like, we can change the variables up here, like the minimum size and the maximum size don't change them.
Yeah, and the light conditions as well.
Yeah, and how frequently we will change, we will capture an image, and what,
yeah, null pointer exception.
yeah, we
We
also
love
have a
it.
bug.
We also have a bag.
But we blame the framework for it because I can't find it.
It's the .NET framework. We cannot do anything about it.
I think it's some kind of collision. I don't know if it's a memory problem or what it is, but it works somewhat. Well, most of the time.
We need to have this one also.
Yeah, we need the music.
Yes, for the preview, of course.
Sadly, I couldn't choose music. Or happily for you. Ja,
Okay.
kvadrant, ja.
Let's show you the Java application as well. Okay.
That actually looks like the mock
No,
object.
I will do that.
Because we
the frame
have-
should be bigger. Let's
Yeah.
connect it. Now,
Okay,
Yeah,
I
no.
don't let me crash now.
now you can see. Okay, so now I got in a state of starting the music playing. You can see here I will turn it off just to start. The balls are painted and in this picture, and if he moves the balls like you saw previously, he had them up, then the music starts playing. We have different cases like this. If he, as Stefan showed earlier,
Whoa, too high. So,
I could turn the music
what?
back on.
Yes, do so.
If you take
And what we had play down,
both,
both down. Play.
yeah,
And then we can change tune.
didn't ta upp den igen.
Uh,
Jag får komma höger. Har den hittat?
Denna måste ner. Okej, så.
Then we change the track.
And we can pause it also if we want to.
So basically the different settings, as we showed earlier in the presentation, is regulating the printout and is regulating the Winamp application. We can show all the cases once again just to refresh the memory. We had it here in the beginning. So these are the cases we have. If both balls are down, we'll start playing the music. And yeah, you can see for yourself. So it's
So let's play a tune and we take next tune and then we exit. Alright?
Okay, try.
Yeah, let's
Yeah, 3 shapes.
play.
Ja, det var på den sidan.
Okay.
So now, okay. It should play now, man.
No, you only have one ball.
Yeah, no.
Too close.
Okay, wait, I was outside. So,
Yeah, that's the paper playing part.
oops.
Okay, and the total
Also, and now we change. Note change, okay. Then we have to play.
You can see why this mock object makes sense. Sit still. Du måste
Oh, wait.
Du ska inte ansiktet med i bilden.
Okay, I will try to sit still.
Like you see, this is very, very hard to debug.
I could actually show how this mock object is working a little bit more. Yeah, you see why it makes sense to use the mock object.
It's not really easy to try it yourself, man.
Yeah, it's hard.
It's
Okay.
okay, so this is the debugging environment we use instead. So we could change the balls. Okay, it says exception since I have not have the music on. Okay, so in this we could debug it instead and do the different cases without using the webcam. So you can see why the mock object makes sense of instead of using the camera at all time.
Yeah, exactly. It's actually really hard.
Yeah, it is. And it would
You have a dog t-shirt, or you can try it. Samma.
Nej, jag har samma... Men det är paus, eller?
Respiratorflyktare. Stopp! Nej, stopp!
That's basically, we could probably sit there for another 5 minutes and we'll probably get it to work better with the balls itself. But yeah, that's the basic functionality of the program.
Yes, any questions?
Actually, I can say something. Actually, I think this idea is very good because maybe you can connect this webcam with these balls to some other IP, like some small robot or something that makes the movements. So it's very good thinking. But yeah.
You could have different light settings, like on a show you could have different light settings on the wall and stuff like that. You could, and then change, yeah, you could change anything. This is just a Winamp, but you could have basically anything. It's pretty cool.
Yes, it was a fun project, but too short maybe for using video.
If you had more time, what would you like to change?
We would like to change pretty much the C#.
Some more stage when you can go back and reset. reset it. So you can go from play to next and from, and then you can reset and go to next again.
The first idea was to have 4 balls as well.
Yeah, that was fine.
Something else? Otherwise, thank you very much.